Hi, let's take a look at evaluating functions. So in this video we're going to take a look at function notation, evaluating functions, and also composite functions. And I've got 6 different examples that we're going to go over and solve and explain. So let's take a look. Okay, so in function notation, this is read f of x equals 3x plus 2. So we're not multiplying the f and the x. Usually when we have two things next to each other, we're multiplying two things together when they're next to each other. But f simply just names the function. And then x is the variable that we're putting into the function. So x is the input, f is the name. So we would take f of 5 and evaluate that. We would take our function, and then we would put 5 into the function, and then we would just evaluate that. So f of 5 becomes 15 plus 2. Combine those terms, and we get f of 5 equals 17. So when we write it like that, it shows us what we put into the function, the 5, and what we get out of the function, which is a 17. Now we can also evaluate a function using an expression. So rather than putting a number into a function, we can actually put an expression into a function. So we wanted to calculate f of x plus 4. Then we would take the function, and we would put x plus 4 into the function for x. Now notice I put parentheses around it. It's usually best to put parentheses around it because that takes the place of x. So the whole x plus 4 takes place of the x. So we're going to have to multiply the 3 by the x and by the 4 using distribution there. So that'll get us 3x plus 12 plus 2 when we do distribution. Then we combine the 12 and the 2, and we get f of x plus 4 equals 3x plus 14. So now let's take a look at a composite function. So if we have two functions, one is named f and one is named g. F of x is 2x plus 3, g of x is 4x. And if I was to ask you to find the f of g of 2. So this is a composite function. We work from the inside out. So we first have to find g of 2 in order to do this. So g of 2, we take the function g, which is 4x, and we put 2 into it. And then 2 times 4 just gets us 8. So that's just the inside part, the g of 2. So g of 2 equals 8. So now if we take the f of g of 2, now that we've calculated that g of 2 equals 8, we can take and we can put 8 into that function. And then we just simplify the math. 8 times 2 is 16. 16 plus 3 gets us the 19. So that's how we would do a composite function. Okay, we have 6 examples of evaluating functions that we're going to go through. Let's take a look at the first one. First one's pretty straightforward. So we've got f of x is 5x plus 2. We're going to evaluate f of 3. So f of 3, we're going to put 3 in for x. 5 times 3 plus 2, or 15 plus 2, and we simply get 17. So f of 3 is 17. Okay, example number 2. We have x multiple times in the function, so we just have to put in 2 for both of those x's. Anywhere there's an x, the variable is going to go in. So if f of x is 2x squared plus 3x, then f of 2, we put 2 in for every x, so it's 2 times 2 squared plus 3 times 2, or 2 times 4 plus 6, 8 plus 6, or 14. So f of 2 in this case is going to be 14. So in example 3, we're not putting just a number in, we're putting an expression in. So we're being asked to put in x plus 3 into there. So if we've got g of x equals 7x plus 9, and we're putting x plus 3 in. So g of x plus 3 is going to be 7 times x plus 3 plus 9. Now I want to show you a common mistake here. So if you would go, okay, that's 7x, and combine the 9 and the 3, you would get the wrong answer. So anytime you put in the x plus 3, the whole thing is going in for x. So the easiest way to do that is to put parentheses around what you're putting in, because all of that has to be in for x. So then here, the 7 has to be multiplied by the x and by the 3. So we're going to get 7x plus 21 plus 9, or 7x plus 30. So the g of x plus 3 is going to be 7x plus 30. So in example 4, we're given what h of x equals, and we want to be able to find the value of x. So we're just going to take for h of x, and we're just going to say that equals 7. So we know the output's going to be 7. So let's find out what input for x gives us 7 for an output. So then we just solve this equation. Add 25 to both sides. 32 equals 8x. Divide by 8, and we've got that x equals 4. Example 5 is a composite function. So we've got g of f of 4. So we first have to figure out what f of 4 is before we can figure out what g is. So f of x is x squared plus 1. So f of 4 is going to be 4 squared plus 1, which gets us 17. So this f of 4 becomes 17. So g of f of 4 is the same as g of 17, because we just figured out that f of 4 is 17. So g of 17, if we take g, which is 3 times x plus 4, is going to be 3 times 17 plus 4, or 51 plus 4, or 55. So our final answer for g of f of 4 is going to be 55. Okay, so on our last example, we have a composite function again. We're doing g of f, but then we're also putting an expression in rather than just a number. So the first thing we've got to tackle is this, the f of 2x plus 1. So f of x is x squared plus 1. So f of 2x plus 1, we're putting that in for x, so we're going to put parentheses around it because the entire thing, 2x plus 1, is going in for x, so that whole thing has to be squared. We square this out. You can use FOIL or another method to square this out, but we're going to get the first term squared, 4x squared. We're going to get a 2x twice, so we're going to get 4x. And then 1 squared is going to be 1. And then plus 1. That last plus 1 is just from the function right there. And then just combine our like terms, and we get 4x squared plus 4x plus 2. And that is f of 2x plus 1. So now we can take that. That becomes our f of 2x plus 1. So now we can do g of x, which is 3x plus 4, and we can evaluate that for 4x squared plus 4x plus 2. So that's going to be 3 times all of that, and then plus 4, which is just the plus 4 from there. Multiply our 3 out, and we get 12x squared plus 12x plus 6. And then the 4 is by itself. Combine our like terms, and we get that the g of f of 2x plus 1 is going to equal 12x squared plus 12x plus 10. Thanks for watching. If you have any comments on this video or suggestions for future videos, just comment below. If you'd like to subscribe, you can do so right over here. And I've got another suggestion for you to watch right here. Thank you, and come back again soon.